The following podcast is sponsored by Structure Tech.
I'm going to toss this over to Ruben because this is going to be a geek session on electricity.
You know, the NEC, the National Electrical Code, you could call it a model code, but more importantly, it's an installation standard.
Welcome, everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Ruben Saltzman and Tessa Murray, as always. And we are here on today's episode with a special guest. This is part 2 with Mr. John Williamson, Operations Supervisor with the Minnesota Department of Labor and Industry. And we're here to talk more electrical. I'm going to toss this over to Ruben because this is going to be a geek session on electricity. So I don't fall in the electrical geek world. I'm good enough to navigate this ship into the deep water, but now I'm going to turn it over to the captain, Mr. Ruben Saltzman.
Thanks, Bill. I'm sure John would appreciate us mentioning that today he is not acting in any capacity as anybody official with the state of Minnesota, right, John?
Yes, I'm here just to share information. So what's the great disclaimer? Any opinions expressed today are solely my own or something like that.
That's perfect. We've heard that sped up many times. We all get the gist of it, I think. And that applies to you today.
I should do that disclaimer on everything I say. These are my opinions. They are not those of Structure Tech or Structure Talk.
Yeah. The opinions expressed in the show are solely those of the author, not the blah, blah, blah. Yeah. All right. So, John, last time we had you on the show, we were talking about NEC updates for Minnesota. Well, actually, we're just talking about NEC updates. What's kind of interesting about our electrical code here in Minnesota is that we adopt the whole thing. I mean, with the building code, we adopt the residential code, the international residential code, and then we chop it up and we make a million amendments to it. And we just kind of put our own flavor on it here in Minnesota. But for the NEC, we just take the whole thing and we say, there it is, right?
Yeah. And during this recent adoption process for the 2020 NEC, you know, the NEC, the National Electrical Code, you could call it a model code, but more importantly, it's an installation standard. The building codes, on the other hand, truly are model codes. They're model codes that can be amended at the local level. We don't have earthquakes have been outlawed in Minnesota. That's what I've been told. So we don't have any earthquake provisions in our code, in our building code. There's snow loads and wind loads. There's all sorts of regional factors that come into play when it comes to adopting building codes. So jurisdictions will select a model building code, and then they'll go through the process of amending it for their jurisdiction or region or state or county, whatever. The electrical code, when you stop and think about it, NFPA has 300 different codes and standards that they develop. The NEC is first and foremost, it's just an installation standard. It doesn't talk about licensing, doesn't talk about permits, doesn't talk about inspections. And unlike the development of building codes, the electrical code is really amended prior to its publication. In fact, the 2023 NEC is in development right now.
Okay. So now, the last time we had you on, we were kind of in the process of adopting this code, but it has been adopted now. That was like a couple of months ago, and now it's official, right?
Correct. Yep. The process started back in January of 2019. The Board of Electricity passed a motion to get the ball rolling, and the 2020 NEC was essentially available for review online during all of 2019. We fast forward, there was meetings and discussions and whatnot. The intended adoption date usually is July 1st of the year that the code comes out. So looking ahead, the July 1, 2023 will be our target date for getting that code adopted. But anyway, housing industry, they requested that we have a hearing as part of the rulemaking process. So we did that, but due to COVID, the Office of Administrative Hearings, they had constraints put upon them due to the COVID pandemic, just like all of us. So the hearing didn't take place until August. Administrative law judge issued a report recommending that we move forward with the adoption of the code. And by virtue of that, the administrative law judge essentially didn't find any flaws in our rulemaking process. One minor little thing, but for the most part, the judge said, yeah, you guys, you did the right thing. included the public. So we moved forward with the adoption and the wheels kept turning. And the way it worked out, November 17th was the adoption date and the effective date for the 2020 NEC.
So, John, I just want to jump in here real quick. Can you explain what NFPA is and why it matters to NEC? And maybe just drop what is the NEC?
NEC is the National Electrical Code, and the NEC is just a familiar acronym. NFPA is the National Fire Protection Association. And so National Fire Protection Association, they have about 300 codes, standards, and recommended practices. They actually have their own building code. So that's just yet another model building code, similar to the other model building codes out there.
Just to ask a quick clarification question, does the NEC come from the NFPA?
NFPA is the shepherd. They guide the process. Yes, the NFPA staff, they essentially are the host and they shepherd the process all the way through, but NFPA staff are not the ones writing the code. The code is developed by a wide variety of people. It's a public, open consensus process. Anybody can partake in that process. So it's a very open process and it's done online. That was one of the things at the Builders Association, unlike the building codes, where usually the amendments aren't considered until you actually have a physical copy of the code in front of you. The NFPA, all of standards that they develop and are responsible for, those are all done online in real time, which is pretty amazing when you think about it. And so a lot of people just haven't quite figured out yet how to plug into that process. Hopefully that answers the question.
At least these are things that don't need to be changed on a regular basis. And
yeah,
John, it's funny to me that you're already talking about changes for 2023.
Yeah.
The obvious question that pops into my head is, well, why didn't you make changes now? I mean, if there's stuff on the table, does it take that long to actually move these things through this process?
The 2020 NEC was published last fall. It was published in September of 2019. And as soon as a new NEC is published, the door is open basically for the next 3-year cycle. And public inputs, as they're now called, they were due for the 2023 code. They were due by September 9th or 10th of this year. Those public inputs are online. They're already available online. In fact, one of my colleagues is attending virtually. He's on a code panel, and he's going to be meeting all next week with his fellow panel members, reviewing all the public inputs for the 2023 code. So it's a lot to take into consideration. Here we are, we're just adopting the 2020 code, and yet the 2023 is already in motion.
Bless your friend's heart. I mean, that's wonderful. And that sounds like the most boring Zoom meeting I could possibly imagine.
Unless you're a code geek. If you're a code geek, good stuff.
I appreciate people like that. All right. No, I want to kind of pick up where we left off, John. We were talking about some of the new requirements that came out, and you told us about this new requirement for GFCI protection, basically for almost all outdoor outlets. And I re-listened to the last podcast, and I had said receptacle. And I remember Tesla's like, Ruben, why do you say receptacle? And I'm like, I don't know. I mean the same thing as outlet. But I realized I had a good opportunity. It was a good learning moment, and I blew it because really I do say receptacle a lot of the time when I'm talking to people like you, John, because there's a difference. An outlet is anywhere that power is utilized. It's like it could be a light or a smoke alarm, or it could be a number of different things. A receptacle is something that you plug a plug into. Did I butcher that too much, Sean? Does that sound about right?
No, we're going to make an electrician out of you one of these days. No, that was good. Yeah, an outlet defined in the code is just a point on the system where power is derived or current is derived. And you're right, it could be a lighting outlet, a receptacle outlet, an equipment outlet, appliance outlet, smoke alarm. It's just a point on the system, a junction box or a cable sticking out of a wall where you make connection. The receptacle outlet is specifically talking about, the actual device.
Excellent. Thank you. So one of the things we talked about last time is that now you need GFCI protection for outdoor outlets. And I guess we didn't really dig into that to make it clear. We're not talking about outdoor receptacles because GFCI protection is already required for 120 volt receptacles, but now you need it for outlets. And that's
Correct.
like anywhere power's coming out. Like for an air conditioner outlet does not mean a receptacle you plug an air conditioner into. It's basically, where does the outlet begin? Is that the disconnect box?
Yeah, or junction box. Yeah.
Okay, sure.
So yeah, I mean, if you visualize a new home under construction and they just sheetrocked it yesterday, you got all these boxes sitting around with wires pushed back in the box. That's an outlet.
Okay,
That's an outlet. It's a good way to visualize an outlet. Yep.
cool.
So not to interrupt you, but the simple way to think about it is it covers. It's not practical to ever plug in a AC condensing unit.
No.
It's probably not even allowed by the manufacturer. But that new provision, which we can dig into, that covers cord and plug connected equipment or hardwired equipment, like a condenser is typically done. So it's a big deal.
And something that threw me for a loop just a little. I thought I knew the answer, but I sent you an email a couple of weeks ago just to verify this. It says that it's needed for all branch circuits rated at 150 volts or less to ground. And I was like, well, wait, how does that cover 240 volts? Is this measuring each leg on a 240 volt and measuring that to ground? And you were very kind with your long explanation, which basically just said, yes, dummy. It's it's line to ground, not line to line. On a 240 volt circuit, you got two hots. And when you measure the voltage from hot to hot, you got 240 volts. But if you only take one of those and you go to ground, it'd be half that. It'd be 120 or 125, whatever it is. And so with that language, when they're saying you need GFCI protection for 150 volts or less to ground, it pretty much covers everything residential, right?
Yes, it does.
Okay.
Yep.
All right.
Yep. Real briefly, the reason the code talks in those terms or uses that methodology, it has to do with UL standards or product certification standards that are applicable to circuit breakers and devices. And so you've got all these standards that are out there that kind of use this technical way of establishing the ratings. We also have to keep in mind the National Electrical Code is adopted in other countries. There could be areas in the code, it's not going to be applicable in a residential situation, but there's other areas in the code where you have systems in buildings, especially in industrial places, where you've got these oddball systems that will have a different voltage to ground or different voltage line to line, but they all fall within a specific category. So it's about establishing categories to make sure that all the different systems are covered. So when the electrical code talks about a single phase branch circuit rated 150 volts or less to ground, 50 amps or less, that's basically everything that you would find in a residential situation or a home. The whole emphasis, and we can talk a little bit about the history, but the public input came about due to some fatalities related to air conditioning equipment. So that's how they established that threshold: 150 volts or less to ground, 50 amps or less.
Now, what if you have a 60 amp compressor?
That did not get looped in. Now, I talked to a colleague the other day. There was talk about revisiting this section in the code, 210.8F, to change that 50 amp threshold up to 60 amp, because that was really what they were really meant to do that. But the explanation I got from my coworker was that what we're talking about here is the rating of the single phase branch circuit. And this language was somewhat borrowed from another area in the code that was dealing with receptacles.
Okay.
We're not dealing with receptacles here. We're dealing with the circuit itself. And 50 amp is a common threshold for receptacle ratings. 60 amp is a common threshold when you're talking about circuit breaker ratings. So it's really just a technical issue in the code. It doesn't have any specific intent behind it. What it did do, obviously, being that the threshold is set at 50 amps, it does loop in all of the 30, 40, and 50 amp air conditioners that are out there.
Sure. Okay. And then one more thing on this topic. Before we leave this, it's saying that you need GFCI protection for these outdoor outlets, but based on our definition of an outlet, that's also a light fixture. So it seems as though it should include lights. However, there is an exception. It says that outdoor lights are not included in this requirement. And I'm kind of curious why, because I look at my own house and underneath my deck, I wanted to have some nice Christmas lights that are turned on and off by the flip of a switch. So I unscrewed the light bulb in my floodlight and I installed one of those little socket adapter thingies where it lets me plug Christmas lights into a plug, turns my light bulb into a receptacle. Now I'm at risk of electrocution. Now, of course, I'm a smarter homeowner. And before I did that, I installed the GFCI breaker in my main panel just to make the whole thing safe. But who's going to do this? Right?
Yeah.
And why don't we just include outdoor lights?
You installed a GFCI breaker in your panel for that?
I sure did. Absolutely. I've got a hot tub pretty close by. So,
Ruben, did you pull a permit? Did you pull a permit for that work that you did in that?
You're not letting John ask the question. Let's answer the question, Bill.
Yeah. So there's two things I'll respond to. Those adapters you see at the home center, there's a million different configurations of adapters and different things. They're meant to be used indoors. If they're used outdoors, they're really not weatherproof rated. If it's under an eave, it's probably not the worst thing in the world, but they're still not damp location rated. But anyway, in holiday lighting, Christmas lighting, those are listed and labeled products intended for short-term seasonal use, 90 days or less. So yes, people will do things that they need to do to get their lights on, their holiday lights. Hopefully those things are taken away at the end of the season. But to get back to your main question, one of the criteria, I guess we'll call it, in the code development process is to make sure that any changes in the code have merit. They have to be substantiated from a technical perspective or a safety perspective. The code, even though there's hundreds and sometimes thousands, I think for the 2017 code, there was 5,000 or 6,000 public inputs or proposals, as we used to call them. So there's a large number of proposals that come in. A lot of it is just editorial, but for a major change to take place in the code, there has to be a reason for it. And when the code panel and the industry was reviewing these public inputs, the public inputs were put forward because of these fatalities. That was, it's a serious situation. However, none of the fatalities resulted from a light fixture or from a lighting outlet. They were all due to equipment malfunctions, air conditioning equipment primarily.
So basically, there's no body count for this. So we're not going to change the rules because there's no way to prove that it's even needed, right?
Right. So when you go in and you look at the archive for the 2020 code, you'll see that the panel statement says that lighting was exempted because they had no tangible reason. There was no technical or substantiation that warranted including lighting outlets.
Well, that's perfectly logical, and I'm glad that it is that way. That makes a lot of sense. And
so, John, if I could jump in real quick, I have a question. Who are the people who are submitting these public comments? Are they typically attorneys because a lot of this is resulting from litigation, or is it just an electrical contractor or manufacturer, or who by and large are submitting all of these requests? Based on all the years I've been doing it, most proposals that come in or public inputs are people that are in the industry. They're in the trenches. They would like to see the code change for some particular reason. They're just engaged every day. It could be an attorney, but it's usually electricians, contractors, electrical contractors, inspectors, testing laboratory people, manufacturers, the same people that are submitting public input. It's a time commitment. There's no question about it. It takes time to put your thoughts together and to log in and put your inputs in. And then, of course, in our busy lives, all of a sudden, oh my gosh, September 10th, I've got to have these proposals ready to go. So, there's that part of it too. But the people that partake in the code development process, for the most part, are the same people that are actually represented on the code panels. The code panels are structured that there cannot be, no one category can control a code panel. It's a very diverse group. I don't have a list in front of me, but basically the code panels are made up of manufacturers, testing laboratories, labor organizations, contractors, inspector organizations, a wide group of people. And those are the same people that are
they're code geeks, and they're engaged with the process, and it's easy for them to submit public inputs. And I'm sure there's probably inputs that come forward due to litigation. It would probably come from an insurance industry person.
Okay. And then one other question before we get off of this exterior GFCI protection. When you've got these larger amperage resets, or you've got the GFCI on the branch circuit, where does the reset typically live? Is it at the breaker? Is it in between the breaker and the device? Is it right at the device? Where's the reset button?
Well, for GFCI receptacle, the test and reset functions are going to be, on that receptacle.
Mm-hmm. But in air conditioning, if it's hardwired, where are we going to find it?
Well, for new construction, it's going to be back at the main service panel. That circuit breaker will have a test and reset function on it. If you have a retrofit situation, that you might not be able to get a circuit breaker. You might not be able to find a matching circuit breaker for that existing service panel. You might not, there might be a mismatch on brands or whatever, or maybe that electrical panel is out of date and they're not making breakers for it anymore. In that case, you might end up having to put a circuit breaker enclosure adjacent to the AC condensing unit outside. And then that's where your test and reset.
Well, and that would take the place of the disconnect, right? I mean, that would become the new disconnect.
Yep. It would function. A GFCI in and of itself is not a disconnecting means. You can't use the test button as a disconnecting.
But if it was a GFCI breaker, you could flip the breaker off, right?
Yeah.
Okay.
Oh, yes, absolutely. Yes.
Got it. Although it sounds as though Minnesota made a special exception to the enforcement of this right now because of lack of breakers. Is that right?
Yes. Despite all of our effort to notify the industry, everybody's been waiting for the 2020 to become effective. But then despite our best interest to notify the masses, some people were taken by surprise. And then immediately the comments back to us was, we're having a difficult time finding GFCI breakers, AFCI breakers, let alone 2-pole GFCI breakers. Due to the COVID crisis, there are supply chain issues across the world. I know a guy that was a representative for about 30 different manufacturers here locally. And he's like, there's ships parked off the West Coast that can't be unloaded because dock workers are stricken with COVID, or the factories in Indonesia and Asia are stricken with COVID. So there's some huge supply chain issues right now. I got a little project here at home. I needed some PVC conduit, and I went to the big box store and I couldn't find what I needed. I mean, just everyday stuff is just not there. We decided we're not going to enforce that provision 210.8F. And the way we can do that is in the code, there's a provision that says the authority having jurisdiction, the AHJ, if the code is mandating the use of a new product and it's not yet available, we can just use the old or the previous code for the time being until the products become available. So we're kind of using that as justification for not enforcing that provision in the code right now.
Sure.
At some point, the supply chain issues will get resolved, and those 2-pole 30 and 40 amp GFCI breakers will be available, and then we'll just move forward like we normally do.
It was helpful for me to hear that. I had a project I was working on at my house. I was going to put in a 240 volt space heater in my basement bathroom, and I could not find a single 240 volt GFCI breaker. I mean, all of the 240 breakers were cleared out on the shelves at all of the big box retailers. And I was just going, what the heck is going on here? But now I get it.
Yeah.
Ruben, is that the bathroom that already has the in-floor heat built in?
It's the same one. Yeah.
You just need more heat?
Well, the in-floor heat is for your feet, Tessa.
Oh my God. It radiates up. It makes the whole space warm.
I don't
Apparently
keep it,
not warm enough.
I don't keep it at 90 like you do.
Oh no, that's not me.
I know that's Jay. That's Jay.
He would love to use that
No,
bathroom.
it's actually that in-floor heat is not cheap. We've talked about this. I've got one of those electric meters where my phone will tell me how much power I'm using right now. And when that in-floor heat kicks on, you see a big jump in your house's electrical usage.
Really?
So
I haven't tracked it. I have no idea.
Yeah, it's a lot.
I don't want to know.
I keep it at a modest, like 75 degrees at the floor. It's not enough where your toes are toasty. It's just that the floor's not cold. That's it. It does not warm up the bathroom. But
First world problem, Ruben.
This is not a problem.
You should, you know what? The European countries have a lot of heaters where they like can actually hang their towel on them, so when you get out of the shower, you grab a warm towel.
I'm not that luxurious. I never will be.
Are you guys familiar with the Panama shower head? It's an electric shower head.
What does
Have you
it
ever
do?
seen one of those? What does it do? It heats the water as the water passes through the shower head. It's electrically heated. I've seen it in Central America. I've seen it before. Basically, there's just two wires coming out of the wall going to the electric shower head, and
What could go wrong?
Yeah, exactly.
Well,
Yeah.
but you know what, John, that brings up an interesting topic, because that's another thing that changed in this new version of the code. And we touched on it last time. You brought it up in the last podcast, but I've heard some other sides of the story or some different opinions on this one. So I want to talk about this for a minute. So you've got the Panama shower head, and it's got two wires coming out of it. You got to plug it in. Where are you going to plug it in? It used to be that the requirement was you need a receptacle, not saying outlet, you need a receptacle within, what was it, like 3 feet of the sink? Is that right?
Yes.
Okay.
Mhm.
So you needed an outlet within 3 feet of the sink, but now we're saying you can't have that receptacle within 3 feet of the shower. Or if it's a bathtub, you basically draw a line straight up from the lip of the tub. You go 8 feet up and then you come on over. You can't have it in that zone. Well, 8 feet up and 3 feet out. Sorry, I didn't clarify there. There's like a 3 foot zone where you cannot have receptacles anymore. And it seemed logical. I mean, we've already had that restriction for chandeliers. You can't have chandeliers above your bathtub and some other similar luminaires. But now that we've added this to receptacles, it seemed like a good idea. But I heard some other people taking the other side of the argument and saying, this doesn't make any sense. It's always been fine. Luminaires are a different beast because they're not GFCI protected. The receptacle that you got to put by your sink does need to be GFCI protected. And, what about the kids who want to sit in a tub and have their phone on and they want to have it plugged into a charger? What are they going to do? They're going to use a low voltage charger. They're going to plug it into the outlet. And if they drop their phone in the tub, nothing's going to happen. They'll fry their phone, but that's about it. You're not going to kill anybody. But now you move that outlet more than 3 feet away and a kid wants to charge their phone. What are they going to do? They're going to go get an extension cord. And it's like, what are we doing? Are we making things safer or more dangerous with this code update? I'd like to hear your thoughts on this.
Yeah, the genesis for that, and I don't remember the specific public input. I don't know that there was a fatality, for example, or a body count somewhere, but the idea was that forever we've had this provision in the code that you mentioned, the zone. Picture this invisible zone, 8 feet high, 3 feet out from the tub or the shower stall. And within that zone, you couldn't have any kind of pendant lighting or swag lighting or chain hung lighting or track lighting, paddle fans. You couldn't have anything that somebody would be tempted to grab out of instinct. If they were slipping and falling in the tub or trying to steady themselves, you don't want people grabbing something like that, either intentionally or just out of instinct. So we've always had that provision in the code. The code does allow, obviously, recessed lights over a bathtub and shower stall, either damp location or wet location rated, depending on circumstance. You can even have a wall sconce on a wall. If you got a big bathroom with a big tub and a beautiful marble surround, the code would not restrict you from having a wall sconces in that location. So the idea is to just take that concept and apply it to receptacles to avoid the situation that I have in my very own bathroom here. When I wired my house back in '86, the basin area is accessible from the master bedroom and from the hallway. The toilet closet and where the bathtub and shower is a separate little cubicle. And I wanted a receptacle in there for whatever, maintenance. I'm an electrician. I put receptacles all over the place. So I got a receptacle on the wall. In fact, it's almost underneath the toilet paper holder. It's about 12 inches off the floor, but it's like 2 feet from the tub. There's nothing stopping somebody from sitting in that tub and plugging in a portable TV or radio or whatnot Not that we would ever do that, but that's the hazard they want to go after. They want to eliminate people doing that. However, when they developed the language for the 2020 code, they just borrowed the language for light fixtures or luminaires, and they didn't run that zone down to the floor.
Yes.
So that's a change that we're probably going to see in the 2023 code. They're going to modify the language to kind of close that loophole or that gap that was created. A lot of times when changes come out in the code, they don't necessarily get it right the first time. There's already half a dozen proposals to fix that provision in the 2023 code. So what I'm visualizing moving forward is that this zone will be 8 feet high, or it'll go down to the floor. Right now it starts at the threshold of the shower stall or the edge of the tub, the lip of the tub, and goes up, but it doesn't go down. So they really didn't solve the problem they were trying to solve. We also have the provision in the 2020 code that says, okay, bathrooms that are too small to meet this specific provision, they just want you to get that receptacle. It's got to still got to be within 3 feet of the basin, but put it on the wall farthest away from the tub or shower stall. And that in itself is not the best way to approach a code. It becomes more of a performance issue than a prescriptive issue. So when you're dealing with performance provisions in a code, you kind of leave it up to the owner and the electrician and the home builder to kind of figure it out. And sometimes that's good. It can be a good thing, like for kitchen counter outlets and island outlets and peninsulas and stuff. But sometimes it just creates an environment for people to argue too at the same time. So hopefully they'll clean that up in the 2023 code. So it really comes down to common sense. Keep the receptacle within 3 feet of the basin, but keep it away from the tub and shower to the extent possible.
Okay. All right. I think just one more question that I had that applies to what we see as home inspectors regularly. And there's a new requirement. It's 422.5A, which deals with sump pumps. Well, it deals with a whole bunch of appliances that now need GFCI protection. But the two big ones that jumped out at me were sump pumps and dishwashers. Can you just enlighten us on those?
Yes. Even though most of the GFCI provisions are back in Article 210, when it comes to appliances, they separated things out and put them in Article 422, which is appliances, but yet they're connected together. They refer back and forth to each other. So yeah, for specific appliances, we've got automotive vacuum machines that you see at the self-serve car washes, drinking water coolers and bottle fill stations, cord and plug connected high pressure spray washing machines, tire inflation machines, vending machines, and then looks like for the 2020 code, they added sump pumps and dishwashers. Now, dishwashers, that's not new. That was in the 2017 code. It was back in 210.8. They just basically moved it to Article 422. So the 2017 code.
But the difference here, before, didn't it apply to receptacles and now it applies to the appliance? Or am I mistaken there?
No, in the 2017 code, there was dishwashers were required to be GFCI protected both for cord and plug connected and hardwired.
Okay.
So that was in the 2017. They just moved dishwashers over here to 422 where it really belongs, along with all the other appliances. Sump pumps, yes, they've been added. Don't have the history in front of me on that, but sump pumps for the most part have always been GFCI protected because they're typically in an unfinished area in the basement, and receptacles in those unfinished areas of basements have always, for the most part, been required to be GFCI protected. So,
well, and with the new code, it doesn't matter if it's a finished basement or not. If it's a basement, it needs GFCI protection, right?
Right.
I think that's all I had on the code updates. And then Tessa had a question about knob and tube.
Yeah, this isn't really a code question, but just kind of a general, I guess, electrical question for you, John, is, here in the Twin Cities, we have a lot of older housing stock. By older, I mean built 100 years ago that still has knob and tube. And a lot of it is still live. And what we find as inspectors a lot of times is that the visible wiring or the accessible wiring has been updated with Romex or something else, but there's still knob and tube running in the walls. So what would you say to a person who's buying a house that has this live knob and tube in it? How big of a deal is it?
Well, it's actually called concealed knob and tube. We just, obviously for conversation, we just call it knob and tube. Everybody's familiar with that expression, but it's concealed knob and tube wiring. And the reason that it's categorized as that is that in the industrial world, in the commercial world, it was called open wiring on insulators. And maybe you've seen pictures of old grain mills and industrial establishments up in Duluth even, or downtown Minneapolis. There's some cool pictures of old warehouses where you've got these big cables running on porcelain insulators. And that was how they wired buildings back then. On the home side, you didn't want that stuff exposed. So then they used smaller conductors, number 12, number 14 conductors, but the concept was the same, except that now this wiring, it's single conductors. They were solid conductors, single solid copper conductors with rubber and cloth covering, and where they penetrated or went through perpendicular to a floor joist, for example, they went through a porcelain tube. And where they were running down the side of a floor joist, they were tied off to a knob. And that's where knob and tube comes from. And so there are literally millions of homes in the United States that still have knob and tube wiring. And you might not believe what I'm going to tell you, but the electrical code allows you to extend knob and tube wiring to this very day. Nobody would ever do that. Nobody would scrounge up a bunch of knobs and tubes, and there was a sleeving material. They called it loom. I've got samples in my office. Nobody would go to an antique store and find a bunch of knobs and tubes and loom and wire and extend their circuitry that way. You would use a piece of NM cable or non-metallic sheath cable. But I'm just trying to maybe not push back, but we have people that just, when they hear knob and tube, they immediately want to condemn it. And the reality is that you can still extend knob and tube circuits in existing installations. Again, 99% of the time, people are going to, if they have access to it, they're going to remove it and replace it with modern wiring methods. But technically, they could extend that. And as an inspector, I can recall a couple of situations where the knob and tube was extended, and they did it in a safe manner. So what do you say to a prospective buyer? If the concealed knob and tube wiring is in good working condition and it hasn't been attacked by rodents, or if it hasn't been overheated or overloaded and the insulation hasn't, dried up and fallen off the conductors, it might be in perfect working condition. But you're not going to know that unless you can see it and then inspect it somehow. I don't know how you go about doing that. The other thing that people need to be aware of and cautious of is the home weatherization that has been going on since the 70s. If you've got concealed knob and tube wiring in the walls of your home, and that wiring now has been encapsulated in some form of insulation, that's a fire hazard. It's a code violation, electrical code violation, and it's also a fire hazard. So we've worked with the weatherization people to make sure that they're not doing that kind of activity. If they're going to weatherize a home and there's knob and tube wiring in the walls, the first thing you need to do is essentially rewire that portion of the home.
You did, and that's actually a great place to kind of put an end to this episode. But it'd be a fun conversation to talk more about knob and tube and that whole encapsulation business, because who's actually enforcing that is interesting to me. Insurance companies are just outright saying, well, we probably don't want to insure that. I don't think everybody's saying that, but I know there's a few that don't want to have anything to do with it. So I think that's a great topic to pick up on another day. So John, thank you very much for your time. We appreciate your knowledge and expertise. It's fun watching you and Ruben go deep on some geek speak. I'm flying a little different level than you guys are at, but I learn something each time we get these opportunities. So thank you very much.
You're very welcome. Thank you.
All right. Well, everybody, you've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich. Happy to be here alongside Tessa Murray and Ruben Saltzman. Thanks for listening, and we'll catch you next time.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.